Imagine for a moment that you wake up one morning and something is profoundly different. The world around you feels squashed. You try to stand up, but there is no up to stand into. You try to look down, but there is no down to see. Everything you know, every object, every person, every single part of your existence is confined to a single infinite sheet of paper. This isn't a dream, this is a journey into a two-dimensional universe. We're going to explore a place with only length and width, a place that scientists and thinkers have called Flatland. What would it truly be like to live there? So, what exactly is a dimension? It's a beautifully simple concept when you break it down. Think of it as a direction you can move in. In our world, we have three. The first dimension is a line. Imagine a tiny creature that can only move forward or backward along a single straight path. It has length, but nothing else. Its entire universe is that one line. This creature lives in a one-dimensional world. It has no concept of left or right, up or down. It knows only the journey along its single restrictive track. This is the most basic form of spatial existence, a universe of pure, unadulterated length. It is the foundation upon which more complex realities are built. Now let's add a second dimension. Take that line and imagine you can now move sideways off the path. You can now go left and right, as well as forward and backward. Suddenly you have a flat surface, like a sheet of paper, or the screen you're reading this on. This is a two-dimensional world. It has both length and width. You can draw shapes on it, circles, squares, triangles. You can create maps and floor plans. This is the world of Flatland. An object in this universe has an area, but it has no thickness. It is a ghost of an object, a mere outline of what we would consider a solid form. It's a world of surfaces without any substance beneath them. Life in a two-dimensional universe would be radically different. Every interaction, every movement, every moment would be governed by the unyielding constraints of the plane. Imagine you are a simple shape, perhaps a circle, living in this flat world. To move around, you would slide across the surface. There's no concept of jumping over an obstacle. If another shape, say a square, is in your path, you cannot go over it or under it. You must go around it. Your entire world would be like a giant, infinitely complex maze. The act of seeing is one of our most precious senses. But in a two-dimensional universe, it would be a strange and limited experience. In our three-dimensional world, light bounces off objects in all directions, and our two eyes capture slightly different perspectives. Our brain then processes these two images to create a sense of depth, allowing us to judge distances and perceive the volume of objects. This is called stereoscopic vision. But in a flat world, there is no depth to perceive. Everything exists on the same plane. So, how would a two-dimensional eye even work? The laws of physics that orchestrate our cosmos would be profoundly rewritten in a two-dimensional universe. Let's consider something as fundamental as waves. In our world, waves can travel outwards in three dimensions, like the ripples from a stone dropped in a pond, but expanding as a sphere. Think of sound. When you speak, sound waves travel from your mouth in all directions, up, down, forward, and to the sides. This is why someone can hear you, even if they are standing above or behind you. The energy of the wave spreads out over the surface of an ever-expanding sphere. As the sphere gets bigger, the energy per unit of area gets weaker. This is why sound fades with distance. In a flat universe, waves would behave differently. A sound wave, or any wave, could only spread out in two dimensions, like the ripples on the surface of a pond. Gravity, the silent force that holds galaxies together and keeps our feet on the ground, would also sing a different tune in a two-dimensional universe. In our three-dimensional cosmos, the force of gravity between two objects weakens with the square of the distance between them. If you double your distance from an object, the gravitational force becomes 4 times weaker. This is known as the inverse square law. It works because gravity's influence spreads out over the surface of a sphere. As the sphere grows, its surface area increases with the square of its radius, so the force is diluted accordingly. This law is responsible for the stable, predictable orbits of planets around stars. In a two-dimensional universe, gravity's influence would spread out not over a sphere, but over a circle. We've explored the physics, the perception, and the environment of a flat universe. This brings us to the ultimate question. Could life in any form actually exist there? The challenges are immense, seemingly insurmountable. As we've discussed, a complex organism with specialized internal organs is a topological impossibility. A simple digestive tract would cleave the creature in two. A circulatory system, a network of one-dimensional lines on a two-dimensional plane, would be incredibly inefficient and would chop the creature's body into a series of isolated islands. There would be no way to transport nutrients and oxygen effectively. The very chemistry of life would be in jeopardy. Our journey through the flat universe is coming to an end. We have walked as shadows on a plane, a world of lines and edges, where up is an unimaginable concept. We've seen how the simple absence of a third dimension unravels everything we take for granted. Stable orbits would collapse, the rich tapestry of chemistry would fray, and the intricate machinery of life would be impossible to assemble. The world would be a place of confusing sights and ambiguous sounds, a maze of impassable walls and biological paradoxes. It would be a simple, stark, and ultimately, a sterile cosmos. The universe, it seems, needs depth to be interesting. This thought experiment does more than just entertain us with bizarre possibilities. It holds up a mirror to our own reality. It forces us to see the profound and beautiful consequences of our own universe's structure. That third dimension, which we navigate so effortlessly, is not just empty space. It is the canvas upon which complexity is painted. It is the crucial ingredient that allows for the stable orbits of planets, the intricate folding of proteins, the branching of neurons in our brain, and the very structure of the atoms that make up our world. Our existence is woven into the fabric of three-dimensional space. So the next time you look up at the sky or throw a ball or simply take a deep breath, take a moment to appreciate the wonder of up and down. Appreciate the volume of the world. Our universe is not just vast in its expanse, but also in its depth. It is this third dimension that transforms the universe from a simple sketch into a masterpiece of cosmic engineering. It allows for hidden places, for insides and outsides, for the subtle play of light and shadow, and for the incredible complexity that eventually led to us. We are, in a very real sense, children of the third dimension. And so we are left with a sense of wonder. Why 3 dimensions? Why not 2 or 4 or 10? Is our universe part of a grander multiverse with realms of different dimensionality? We don't yet have the answers to these questions. But by asking them, by daring to imagine what could be different, we deepen our connection to what is. Our 3-dimensional home is a very special place, perhaps uniquely suited for life. And appreciating that fact is the first step towards truly understanding our place in the cosmos. The universe is not just something we are in, it is something we are of, and its dimensions are the foundations of our being.